Okay, we got this problem. They give us two circles, and one is circle is R, and the other one is big R, and big R is bigger than R, so it's like this. And they tell you that K, that is a number that is bigger than 0, it's just a number. And they ask you, what is the difference on the non-overlapping areas? So basically, what is the difference between this area that is here and this area that is here, but the non-overlapping areas? And the data that you're given is basically big R is small r plus 3k, and the other one is kr divided by k multiplied by r minus 6 is minus 1. Pretty complicated data. When you look at this, it's like, what the hell do I do with this? So the starting point is, okay, so let's understand what the question is. As I always say, focus on the question. What do they ask me? Well, they ask me about the overlapping areas. There are two ways of doing this problem. One is we call the overlapping area x. This is one way of doing the problem. And if we call the overlapping area x, we're going to call this is x. We know that what they are asking us is pi multiplied by r squared minus x. This is my first area. Basically, that will be all this part minus all the other part, which is pi multiplied by small r minus x. This is the question. This is what they are asking us. That's one way of doing it, and obviously this will simply result in pi r squared minus pi minus x plus x. So basically you end up with this. This is what you need to know. That's relatively simple, but not necessarily easy to detect. The key here is that you realize that the difference between the areas is actually not depending on anything. So there is no other factor here. That's a catch here. The real catch is that there is no other number here. Literally, I give you the area of one circle, I give you the area of the other one, or I give you the radius, and it doesn't matter how much overlapping there is. The difference between the areas is fixed. That is not naturally easy to see. So that's what makes you realize on the other way of doing the problem. That is, this is a small circle and this is the other one, and they barely touch. That's one way. The other one is they touch a little more. And the other one is the overall is when one is totally inside the other. So the difference between the area here is all this area minus all this area. So in this case it will be, it's the difference between the areas is literally, it's 0 in this case, I guess, because they're not even touching. But in this one, you need to put the big R minus the small r, and this is what we just compute here. Basically, based on that rationale is literally pi r minus r square. But if you do it here, the difference is literally the big area, so pi minus the small area, all of it, which basically gets to the same result. So, and that is not easy to see that you're going to get to the same result. But actually, that's the key point. The key point is that it doesn't matter how much you put it in. The more you make it inside, the difference of the area is the same, because one, you're taking a little bit of area from one and you're taking from the other one, but the difference between the two is the same because you take the same amount from both. That is what is probably the most difficult part to see. Okay, now that we know we need to find this, basically what we need to find is the difference between the squares of the radius. And now we use these two statements. Let's use the first statement. The first statement, well, there's not much to use here. The first statement is not giving you you cannot compute anything based on this statement, because you will not find r, and you will not find this one, and you will not find r minus r in square. You can find r minus r, but nothing else, basically. All this, the only thing that you can find is this, which is 3k, but nothing else. And you don't need that. You need r squared minus small r squared. So that's useless. Let's process a little bit statement B. I'm writing it down here. So statement B is kr divided by k small r minus 6 equal minus 1. So if we process this a little bit, it will be kr equal to minus 1 kr minus 6, which basically will result, this will multiply this. move it to the other side, adding, so it will be plus r, take common factor, minus 6 will turn into 6. That is something that we can probably turn into this, 6 divided by k. Okay, so, and that's also useless because we don't find, so it's not data sufficient. But this one we can combine with a, that we know that is r minus r equal 3k, because we just processed that, and we can combine this one and turn all this into a multiplication. So you multiply this term by this term, and you multiply this side by this side. So r minus r multiplied by r plus r is equal to 3k multiplied by 6 over k. That is actually useful, because then k will get cancelled with k, this will turn out being 18, and this thing is the same as r squared minus r squared, because it's the difference of the squares, and this is 18. Once you have this is data sufficient. So the answer is C, because once you have the difference of the squares, that is 18, you can plug it back into this formula, and this is exactly what we needed. This is 18, pi 18 is the answer, but you don't need to compute the answer. All you need to know is that you will be able to compute it. Anyway, the big point is setting up the formula. You have two ways. One, you assign x to the middle and you compute this and you realize this. Two, you know, or you kind of getting a feeling by doing too many by doing problems, that they're asking you about the differences of the area, and the difference will be fixed when you, irrespectively of how big one circle is inside the other one. And that's not easy to see, but basically if you compute it here, you get this result. If you compute it here, you get the same result. So it doesn't matter how deeper one circle is inside the other one, and you can realize it right away. It will be a little bit of a catch, because the difference between the areas is, well, to be fair, it's not zero. Actually, I realize now it's the big area minus the small area. So it's actually the same. It doesn't really matter how much you compute or how you compute it, it's always the same area. You see, it's not trivial to see, but you realize then. And that's the catch about GMAT. They ask you about the difference of the areas. They don't ask you about the area here or the area there. They ask you about one area minus the other, and that makes it independent of how deep the one circle goes into the other.